Hi everyone, we're going to look at how to perform a Factorial Anova in SPSS. And to do that, you need to have at least two or more categorical variables for your independent variables. And for your dependent variable, you must have a continuous variable. These tests look for main effects and interaction effects. And if you recall, main effects are each independent variable and whether or not they have a relationship to the continuous variable. We're looking at each independent variable by themselves compared to the continuous variable or the dependent variable, as well as how the independent variables may be interacting with each other and both of them together compared to the dependent variable or the continuous variable. All right, so we'll be doing this in SPSS. So we're going to look at this data here, and we're going to be using gender compared to sports, how much individuals in my classes enjoyed sports, and those are the two independent variables, as obviously gender is a categorical variable. We've recoded the male and female here for this variable. If I switch it off and on here, you can see that we've given males the number 1 and females 2. As well as the individual sports, this has been recoded as well. The numbers represent like, don't care, and then I believe we have a dislike here. Dislike is a 1, don't care is 2, and like is 3. And if we go to the end for our continuous variable, we'll look at the likelihood that each student felt that they would end up having a divorce in the future. And their choices could be between a percentage rate of 0 to 100%. So to start, click on Analyze and then General Linear Model and then Univariate. So our dependent variable is the self-divorce, and then our factors are the gender recode and the how much each person likes sports. So then click on plots, and we're gonna place, let's see, we're gonna place gender recode for our plots. We're gonna chart this into the horizontal axis and the individual sports into the separate lines, and we'll add it here and click continue. So post hoc tests are tests that you would run for any categorical variable that has more than 2 categories. So gender only has 2 categories, so you wouldn't need to run it for this, but the individual sports does have 3 categories: like, dislike, and don't care. So we would need to compare each one, and we will put it into this box here and click Tukey and then continue. And then lastly, select options, and we're going to select descriptive statistics, homogeneity of tests, and then estimates of effect size. So then click continue, and now select OK, and it runs pretty quickly, and you can see here the gender, 1 for male and then 2 for female, and the number of people in each category, and you can see that here. And here we can see the descriptive statistics with the means and standard deviations. Levine's test looks for normality, and this is a test, it's seeing if your data is abnormal. And if it says that it's significantly abnormal, then that would mean that you don't have a good sample. So you, in this case, you do not want to have a significance, and we do not, so that's good. Now, here are the tests for main effects and interaction, and we would look here for significance, and we can see for gender, this is the main effect for gender, right here, where it says gender recode, and this should be 0.05 or less to be significant, and since it is 0.09, it is not significant. However, for individual sports, we do have a significance, as well as an interaction for gender recode and individual sports taken together and their effects on the dependent variable of divorce or self-divorce. This is also significant. And if you come down here, this is the post hoc tests for the individual sports, which are essentially t-tests to compare. A t-test obviously is, you know, you're looking at a group of only two. So when you're doing a t-test, you're looking at one group compared to the other, which essentially is here for the gender recode. It's comparing males versus females. But since we have 3 groups in sports, you do post hoc tests, so it will run a t-test for each possible pair. And as you can see, the asterisks here indicate a significance, and there is a difference between don't care and like, which is indicated here. And then you can continue down, and it gives you, this is where we indicated our plots. We could have changed it around so that instead of having male and female at the bottom, we could have had the sports categories at the bottom, and then the lines represent gender, but we made the lines represent the sports, and the male and female indicated below here. So you can see here people, females were less likely to say that they didn't care about sports than males. But they also indicated there were more females who said that they liked sports than males. However, there were also more women who said they did not dislike, or that they disliked sports more than males. And really what you're seeing here is there are just more females in general in this class. And that's how you would perform a factorial Anova in SPSS.